2024 Chemistry Higher Paper, question 3. Okay, so we're told that we've got some sodium carbonate with the formula of Na2CO3, and we're told it contains Na plus ions and CO3 2 minus ions. We know the atomic number of sodium, and we've got to work out the electronic configuration of the Na plus ion. So I would always, if I was answering this sort of question, just be sketching it out. So I know that atomic number is 11, so there's 11 electrons. So here's my sodium atom. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What a terrible circle that was. However, it's Na plus, so it's lost 1 electron. So actually, this one here has gone. Get rid of that one. So now we're just left with this 2,8. So it'll be that. So we just keep a check on what are you being asked to work out the configuration for. Is it the atom or is it the ion? Explain why solid sodium carbonate cannot conduct electricity, but a solution of sodium carbonate can conduct electricity. This is one that a lot of students get wrong because they haven't learnt the difference between their different bonding types. So I would break it down into my solid and my solution. So in my solid, there is an ionic lattice or ions held together by strong electrostatic forces of attraction. And then, second part is, therefore, the ions can't move. And you must refer to ions. It's ionic bonding. We know that because it's a metal and a non-metal. So it must be ionic, and the ions can't move. In the solution, the ions can move. Again, must refer to the ions. So there's our 3 points for this. 1 mark for the ionic lattice, or ions are held together by strong electrostatic forces of attraction. Therefore, the ions can't move for the second mark. And the solution, the ions can move. Notice I have not talked about electrons. Okay, in ionic bonding, it is the ions which are moving when the current is flowing. Next, then, we have to calculate our percentage by mass of sodium in sodium carbonate, and we've been given a very handy formula to use here. So let's work our way through this. So the first bit then, the total relative atomic mass of the element. Total here is a big clue for us. We can see there are 2 sodium atoms in the formula, and sodium's got a mass of 23. So the top of our formula is going to be 2 lots of 23, which is 46. And that is going to be divided by the molecular mass of sodium carbonate. So sodium carbonate has got 2 lots of 23 plus 1 lot of carbon plus 3 lots of oxygen. And you end up, if you do all of that working out, with 46 divided by 106. And then if you then use this bit and multiply by 100, you end up with an answer for your percentage by mass of the element of 43.4%. Now, where do you get the marks? There's 1 mark for working out the relative formula mass of your sodium carbonate. So 1 mark for that. There's 1 mark for then substituting all of these numbers in together, and then 1 mark for an answer that rounds to that. On this question, if you incorrectly calculated your relative mass, you did get error carried forward marks for getting the rest of it correct after that step. And that's a nice short question for question 3.